When building mobility with zero emissions powered by batteries, you need the best electric motor to provide the rotational energy that produces movement. And Tesla has become good at developing its own engine and showing the level of success that its cars have achieved globally. However, Elon Musk has not rested on his laurels, because he has pushed Tesla to develop even better electric motors. The last result is the new engine that challenges the laws of physics. What is this new engine and how does it beat the entire EV industry? Join us as we explore the new engine, revealed by Musk and Tesla, which challenges the laws of physics. We live in the era of the electric car, and Tesla commands a large part of this action. After centuries of trust in the internal combustion engine, which has caused incalculable damage to the environment due to the carbon emission it produces, the company based in Texas is leading the human attempt to change to mobility with zero emissions. Thanks to visionary Elon Musk, we have come to accept electric cars as a practical means of locomotion, and many of the problems are being solved. While everyone knows that Tesla uses lithium-ion batteries to power their cars, what may not be commonly known is the type of electric motor the company uses and why they were satisfied with this choice. Tesla uses a three-phase CA induction motor instead of a CC motor. Since the lithium-ion battery is DC, you may wonder why the manufacturer of electric cars is not using DC motors. There are several reasons, including that CA induction motors have more torque, even at high speed, have a simple design, are cheap, do not need rare earth minerals, have high reliability, and have a braking system designed easier regenerative. How so? We will briefly explain why. There are several engines with CC engines, brushless or BLDC, CA induction engines, step-by-step engines, etc. Most home electronics use brushed CC engines, such as toys, electric toothbrushes, blades of barbed wire, etc. However, due to friction, the rotative part of the middle or rotor wears out over time. Therefore, after a few hundred hours of operation, these engines fail and need to be replaced with some parts. In addition, if the controller fails, it can open or shorten the engine coil. A short, circuitry coil would lead to a situation of escape. Therefore, for an electric vehicle with an intense and expected performance, C6 powered engines are not a wise choice. And how about the BLDCs? Well, the DC brushless engine has a high starting torque, but its performance or efficiency decreases linearly with the increase in speed. This means that, if an electric vehicle uses this engine, the car will use significant electric energy at highway speed. In addition, at high speed, your vehicle will respond more slowly to your accelerator input. The Toyota Prius has a bad reputation for not being able to accelerate fast enough. The main reason for the slow acceleration is that Toyota uses brushless DC engines in the Prius line. In addition to Tesla, everyone used to crash into electric vehicles because of their slow performance. The slow speed of these EVs is also related to DC engines. But that's not all. Another reason has to do with rare earth minerals. To make a good CC engine, you need permanently strong magnets. And to make these strong magnets, you need rare earth minerals. Before the 80s, the United States had rare earth elements industries, especially in California. However, in the 80s, most of these companies moved to China, to take advantage of lower labor costs and environmental restrictions. Since then, China has controlled more than 90% of rare earth minerals, globally refined, but that realized that when a single country controls an essential element for an alternative product, it can become a gargoyle for the future production of cars. In 2010 it was clear that Elon made the right choice by not using the DC engine that uses rare earth elements. That year China banned the export of rare minerals to Japan because of a diplomatic dispute and tried to crush its economy. As a result, companies in other countries began to rare stock minerals to ensure supply. This led to a sharp peak in prices. So for sure, for a company that plans to make millions of electric cars in 1 year, DC engines are certainly not the right choice. The advantage of the AC induction engine is that its torque property is very close to the ideal characteristic. The torque of this engine is constant up to a certain speed, then decreases, unlike the CC engine. The induction engine does not have permanent magnets, no brushes, no rings, or no position sensors. Its design is simple and has a robust construction. An EV that uses a BLDC engine on a highway is less efficient than an EV with an AC induction motor. Another benefit of the induction motor is the easier and simpler project of the regenerative braking system. In the case of the DC engine, the system is very complicated compared to the induction motor. Tesla clearly got it right with the Model 3's powertrain. It gave its team of engine designers a blank check, a blank frame, and the team created an electric motor suitable not only for an accessible electric car but also for the next Tesla Semi. Tesla's design chief, Konstantinos Lascaris, joined Tesla after the S model had been developed. His head must have been full of new ideas since he co-founded a project to build an efficient electric car. The Tesla Model 3 engine project helped to achieve its declared goal of a 25% reduction in parts counting, making the biggest one do a double job with a heat source to heat the battery. Meanwhile, Tesla is not satisfied with the performance of its electric motor, because it believes that it can extract even more performance from the component. The result of its incessant effort in its electric motor is that the S-Plaid model has become the fastest production car in the world, with performance that puts cars that cost much more than it, shame. The key to achieving this achievement was the carbon-based engine, with greater torque and super high rotations per minute. However, the S-Plaid model is not the only car to benefit from this wonderful electric motor, since Tesla plans to adjust it even more to get more performance in the new Roadster generation. Musk shared unique details about the new engine. The engine is the first to be in production and features carbon rotors. Tesla had to overcome some serious obstacles to get the carbon to roll over the engine. Musk explained that carbon covers it and has different thermal expansion rates, and to achieve the desired result, the rotor must be wrapped in an extremely high intensity, which was difficult to do. Tesla's CEO says the fiber is wrapped around the rotor with a high voltage load, which was previously impossible on a large production scale. Tesla Automation, based in Germany, made a machine for this. Tesla had to build a new installation near the existing Tesla Automation in Prime. It was here that the production lines of new machines needed to produce the innovative engines that would feed the S-Plaid model and the Roadster would be. The main benefit of this new engine is that the rotor, based on carbon, creates a stronger electromagnetic field than a rotor that is kept together by metal, explained the company's boss. Another advantage is that the rotor can go to a higher RPM since this carbon base prevents the expansion of the copper rotor due to radial acceleration. So the new Tesla engine is the most advanced engine in production on Earth. Tesla has a set of new vehicles that are coming to the market soon, including the heavy service ones. For the Roadster, for example, as mentioned above, Tesla will adjust this new engine with carbon bases. It will produce a 0 to 60 miles per hour acceleration in less than 2 seconds. Of course, Tesla wants to speed this up with a SpaceX package, but it was confirmed that the car would use the new electric engine. There is also the Cybertruck, which was initially revealed in 2019 to use a trimeter configuration in its highest finish, which will go from 0 to 60 miles per hour in 2.9 seconds. However, Tesla is now promising a configuration of 4 more powerful engines using the electric motor with a carbon base. Tesla can make the Cybertruck even more powerful and faster. Tesla is also preparing the semi-truck, which is an electric truck class 8 that uses 4 electric motors. The truck was designed to use the same engines as the Model 3. However, by using the new electric model with this carbon base, Tesla can make the truck even more capable. This is necessary for Tesla to be successful in attracting truck fleet operators to make the transition from their operations to electric trucks. In addition to the road vehicles, the new carbon engine can appear in an electric plane that Musk has repeatedly said he is looking forward to designing. Let's hear what you think of this electric motor with this carbon base in the comments section below. If you enjoyed this video, subscribe to this channel for more interesting discoveries.